this part. So initially Na was neutral, right? But if you're reading this equation, how do we read this specific equation? Just tell me. That ma'am, when we have one atom of Na plus, when we have one atom of Na plus, it will gain one electron to form one neutral atom of Na.
Yes.
To form one neutral atom of Na. Am I right or not?
Yes.
Got it? So when we say once we have one atom of Na plus, it gains one electron. So it is going to give me one neutral atom of Na.
Yeah.
Got the point?
Yes.
Then you understand. Then you understand that if we have this, okay, if we have this, another way of reading the same equation would be that ma'am, one mole. Because if we have nothing written on the besides of it, it is going to be what? It is going to be that one coefficient. So one mole of Na plus ions will form one mole electrons to form one mole sodium atoms. Am I right or not?
Yes.
Because I'm reading. So there are two ways of reading the equation. Either you read it in the atomic form, very lowest possible form, that we have very bare minimum one atom. So that is the atomic form. Or we read this in the molar form.
Mm.
Or we read it in the molar form. Got the point?
Yes.
So one atom of Na plus will gain one electrons to form one neutral atom of Na. And one mole of Na plus will thereby gain one mole electrons to form one mole of sodium atom. Yes or
Yes.
no? Okay. So now if I read this, okay, what do we basically mean by the fact that you understand that ma'am the charge of one electron is one single electron is going to be what? 1.602 into 10 raised to the power minus 19 coulomb.
Yeah.
That's the charge of one electron.
Yes.
So thereby the charge of one mole electrons will be what? How many electrons do we have? We have 6.022 into 10 raised to the power 23 electrons once we have. So the charge of 6.022 into 10 raised to the 23 electrons will be what? 1.0602 into 10 to the power minus 19 into 6.022 into 10 raised to the power 23. So once you solve this value comes out to be how much? So this cancels out.
Yeah.
Okay. So how much value do we get when we multiply this specific number? This is going to be 1.602 into 6.022.
Mm.
So this is going to be 9.6472 into 10 raised to the power 4. So if you bring it forward, it becomes 96472 coulomb, which can be rounded off to nearest thousands is going to be 96500 coulomb. Do you understand? So what is 96500 coulomb? This is the charge of one mole electrons. So you understand that one electron's charge is very small, 1.602 into 10 raised to the power minus 19 coulomb. Am I right?
Yes.
One electron charge is this much. But you understand that if we have 96500 coulomb, what does that mean? So one electron charge is going to be what? Minus 1.602 to 10 k minus 19 coulomb.
Yeah.
So the charge of one mole electrons, this is going to be 96500 coulombs. Yes or no?
Yes.
So you understand that this one mole charge electron, which is 96500, this is called as a one Faraday. So Faraday was a scientist. Michael Faraday was his full name. He, for the very first time, he calculated the charge of one mole of electrons. And once he calculated the charge of one mole of electrons, it is going to be 96500 coulomb.
Okay.
Are we understanding? This is going to be 96500 coulomb. Are we
Yes.
understanding this part? So
Yes.
once we do the charge of one mole of electrons, so the bigger unit of charge is what? You understand. If I tell you, you understand. Once I say 100 centimeter is 1 meter.
Yeah.
You tell me which is a bigger unit. If you look at the magnitude, they are exactly, the
Same.
length is the same.
Yeah.
The length can be 1 meter or the length can be 100 centimeters, no matter what.
Mm.
You get the point. The length can be 100 centimeters or length can be 1 meter.
Mm.
Yes or no?
Yes.
So what is the idea? That the length when it is 100 centimeters and the length when it is 1 meter, what does that mean? Tell me. They are equal. But if you look at the unit, which is a bigger unit, so what do you do in that case? What exactly do you do in that case?
The units.
So
It's
the substance, the magnitude which is smaller, the magnitude which is smaller will have a higher unit,
yeah.
and the magnitude which is bigger will have a smaller unit. Got the point?
Yes.
Yes or no? Like
Yes.
it's very simple. Let's say I want to give you 100 rupees. So if I have a 100 rupee note, so one note is enough. But if I have 10 rupee note, then I'll have to give you 10 notes. You
Yes.
understand? So
Yes.
similarly, when the unit is smaller, I will have to give you 100 centimeters to make it equal to 100 small centimeters. So
Yeah.
as to make it equal to one big meter. Got the point?
Yeah.
It's like that. So you understand that when we have this relation, similarly, when I say that 1 Faraday is equals to 96500 coulomb, so 1 Faraday is going to be 96500 coulomb.
Yeah.
Then you tell me which is greater, Faraday or Coulomb? You tell me which is greater, Faraday or Coulomb?
Cool. Cool.
What is bigger, Faraday or Coulomb? It is going to be Coulomb.
Uh, Wait.
Which is bigger? Faraday will be bigger,
Yeah. Faradays.
right? Because the
Yeah.
magnitude is small,
Smaller, but uh, the unit will be bigger.
the magnitude is small, the unit will be bigger. The Faraday is a much bigger unit than Coulomb of charge. Are we understanding? That's the comparison. But
Yeah.
if I tell you that what is the charge of 1 mole of electrons, so you will say it is going to be, ma'am, 96500 coulomb.
Yeah.
And that 96500 coulomb is going to be 1 Faraday. Are we understanding? Got the point?
Yes, ma'am.
Got it? So can I
Mm.
say 96500 coulomb is replaced by 1 Faraday? If I say 2 moles of electron, charge of 2 moles of electron, charge of 2 moles of electron. So that's going to be 2 into 96500 coulomb. This 96500 coulomb can be replaced with 1 Faraday. So that is going to be 2 into 1 Faraday, which is going to be 2 Faradays.
Yeah.
Yes or no? So
Yes.
इसका मतलब directly what I can say that the charge of 3 electrons, 3 mole electrons, here is going to be 3 Faraday. The
Yeah.
charge of 3 mole electrons here is going to be what? Is going to be 3 Faraday. Yes or no?
Yes.
Got it? So similarly, the charge of n moles electron will be what? Will be n Faraday. Yes or no?
Yes, ma'am.
Got the point? First
Yes.
thing. Okay. So n Faraday will be equals to n into 96500 coulomb. N Faraday here is going to be n into 96500 coulomb.
Yes.
Got it? So that's the idea. That's the idea. Okay.
Mm.
Now you tell me. Now you tell me. So when I say that, let's say if I have Mg plus 2, why Mg plus 2? Because magnesium's atomic number is 12. So configuration is 2 at 2.
Yeah.
So initially it is going to have 12 protons is equals to 12 electrons. So when 2 electrons are lost,
Then 10. Mm.
so then they are not equal. So the becomes what? Mg plus 2.
Yes.
Yes or no?
Yes, ma'am.
Yes or no?
Yes.
So Mg plus 2 will gain what? It's going to gain 2 electrons.
Mm.
It's going to have Mg solid. Got the point?
Yes.
Now you understand. Now you understand. Can I read this equation as that 1 mole of magnesium plus 2 ions absorb
Mm.
2 moles of electrons to form 1 mole magnesium atoms? Yes or no?
Yes.
Can you read this equation? Because obviously this is 1, the coefficient here is 2,
Yeah.
and the coefficient here is 1, right? Now, another way of writing down the same equation, I'm going to say 1 mole of Mg plus 2 ions absorb how much charge? 2 Faraday charge. Yes or no? Because the charge of 2 mole electrons is 2 Faraday
Yeah.
to form 1 mole magnesium atoms. Yes or no?
Yes.
Now, going forward, what should I say again? Can I also say that 1 mole of magnesium plus 2 ions absorb 2 into 96500 coulomb charge to form 1 mole magnesium atoms? Yes or no? Got it?
Yes.
Got the point?
Yes.
Got it? And
Yes.
thereby, what is going to happen? What is the mass of 1 mole of magnesium atoms? That is 24 grams. So can I say 2 into 96500 coulomb charge if given to Mg2 plus ions will produce 24 grams magnesium neutral.
Mm. Yes, ma'am.
Got it?
Yes.
So now if the question says that we have passed 40 coulombs of charge to magnesium sulfate solution. Calculate how much amount of magnesium shall be deposited on the cathode. Calculate how much amount of magnesium shall be deposited on the cathode. That's what the question is says. So what does that mean? Just tell me. How much amount of magnesium shall be deposited on the cathode? Got it? So then what do you say? You say that according to the equation when MgSO4 we make a solution, so MgSO4 will make into Mg plus 2 and SO4 minus 2. So if you put it in the beaker and you apply a battery and this battery is providing current, okay. So this is the negative terminal of the battery and this is the positive terminal of the battery. So negative terminal gives it lots and lots of electrons.
Mhm.
So once we have Mg plus 2 and sulfate floating in the beaker, what do you think is going to happen? That Mg plus 2 will go here towards the negative electrode because Mg plus 2 is a cation and cations move towards cathode in the electrolytic cell. This is not galvanic cell, okay? This is electrolytic cell. So in
Okay.
the electrolytic cell, we are not producing electricity. In the galvanic cell, what were we doing? We were using a highly reactive metal and we were
Hello,
yeah.
ma'am.
So
Miss.
do you understand that Mg plus 2 will be
Mm.
attracted towards the electrons? Yes or no?
Mm. Yes.
Got it? So the idea here is what? The idea here is that Mg plus 2 will basically be moving towards the cathode. and it is going to gain some electrons in order to make it neutral. It is going to gain some electrons in order to make it neutral. Yes
Yeah.
or no? So the
Yes.
idea here is what? The idea here is what? Just tell me. Just tell me. That ma'am, so here it is not a galvanic cell. See, understand. Here we are using a battery, and that battery will basically do what? That battery will basically do what? That battery will kind of, okay? That battery will kind of provide electrons. Okay?
Hmm.
So Mg2 plus will thereby be attracting the electrons. Yes or no?
Yes.
Understood?
Yeah.
So what does that mean? So if I write down the equation accordingly, that Mg plus 2, normally we see, normally we see is going to form Mg solid.
Hmm.
Yes or no? So if you read the equation, what do you see from here? That ma'am, 1 mole of Mg plus 2 gains what? Gains 2 moles of electrons to form 24 grams magnesium. Why? Because it is 1 mole magnesium according to the equation. And because it is 1 mole magnesium, what does that mean? That it is going to be what? This is exactly going to be, got it? So 1 mole of magnesium plus 2 ions we have.
Yes.
So 1 mole of magnesium plus 2 ions will give me what? So basically it is going to be Mg2 plus 2 Faraday charge. Yes or no? 2
Yeah.
Faraday charge is basically 2 into 96500 coulomb. If I provide 2 magnesium ions, then I am able to deposit 24 grams magnesium because that is 1 mole magnesium atoms. Are we
Yes.
understanding?
Yes, ma'am.
Understood?
Yes.
What does that mean? What does that mean? Just tell me. Got it? So can
Yes.
I say, according to the question now read, so we have to make a unitary method, right? So we say that 2 into 96500 coulomb, if I provide, it deposits 24 grams. It deposits 24 grams. So 1 coulomb, if it would have been, so how do I make 1 coulomb? I divide both sides by 2 into 96500. So here also, if I divide by 2 into 96500, so what do you think is going to happen? Just tell me. So this is going to be what? This is going to be 1 coulomb here is going to be 24 divided by 2 into 96500 grams of magnesium. Yes or no?
Yeah.
But how much charge have we passed through? 40 coulombs of charge we have passed through to the battery.
Good for
And that is going to divide 24 divided by 2 into 96500 into 40. Yes or
it.
no?
Yes.
Yes or no?
Yes. Yes.
So then you solve for the point.
Yes, ma'am.
So thereby, what do we get? We cancel 1 0. We cancel 2. Then we cancel 2 times 2 4 are 8, 2 8 16, 25. Like that. Alright. So it becomes 24 by 4825. This much grams of magnesium shall be deposited on the cathode.
Yes.
Got the point?
Yes, ma'am.
Any doubts in this? Just tell.
No, ma'am.
You get it? So now
Yeah.
you understand that if I have a general equation like that, what does that mean? So if I have a metal ion,
Yeah.
the metal ion must be having some valency, right? M plus N. It might lose 2 electrons, Mg plus 2, Ca plus 2, Al plus 3. Yes or
Yeah.
no? So a metal can have variable valencies. It will gain, let's say, n electrons to become neutral. So once it gains, got the point.
Yes, ma'am.
What does that mean? So Mn plus will gain n electrons to form n neutral. What does that mean?
There are 2 moles of charge.
Yeah. So I'm going to say that n Faradays of charge. N Faradays of charge because this is n moles electrons, right?
Yeah.
So n Faradays of charge will deposit The gram equivalent, the gram molecular mass of the metal M. Yes or no? Gram molecular mass is the molar mass.
Hmm.
Am I right?
Yeah.
So then what do we get? So one nine Faraday will be what? 96500 coulomb of
Hmm.
charge will deposit GMM of metal. GMM of metal means the molar mass of the metal. Like for calcium, it is going to be 40. For sodium, it is going to be 23. For magnesium, it is going to be 24, and like that. So
Yes.
one coulomb of charge will do what? Will do GMM of metal divided by N into 96500. Yes or no?
Yes, ma'am.
Got it? So this is going to be the general mass. So if I am given random Q coulombs of charge. So Q coulombs of charge will be what? Q coulombs of charge will deposit how much metal?
Into Q.
How much metal? G mm of metal
Hmm.
divided by N into 96500 into Q. So
Yeah.
can I say this is exactly going to be the weight deposited?
Yes.
So you can remember it as a formula where N here stands for what? The valency, and GMM is basically the molar mass of the metal.
Yes.
Am I right or not?
Yes.
So GMM here is going to be the molar mass of the metal. Yes or no?
Yes, ma'am.
So that's the idea. That's the idea. So N Faradays of charge here is going to be GMM of the metal. N into 96500. So you can remember the formula. You can go by unitary method. But this is the ultimately formula that we have. Got
Yeah.
the point? Got the
Yes.
point?
Yes.
Now, this thing, this expression is called as Z. So what is Z? It is called as a this expression is called as what? Z is called as the electrochemical equivalent. Electrochemical equivalent of the electrolyte. And how much is that equal to? That is equals to GMM of the metal divided by the valency into 96500. This is called GMM of the metal. This is the value of Z. What is Z? How do I define Z? It is defined as the mass of the metal deposited. It is defined as the mass of the metal deposited over, it is the mass of the metal deposited over what? Over cathode when 1 coulomb of charge is passed through when 1 coulomb of charge is passed through the right.
Yeah.
So Z exactly is going to be equals to what?
Mass of metal deposited
Yeah.
when 1 coulomb of charges passes.
Correct. So basically, mass of the metal deposited over cathode when 1 coulomb of charge is passed through the solution.
Yeah.
You understand my point?
Yes. Mm.
Got it? So that is Z.
Okay.
Got it? Now understand. Understand. What is current? The question talks about current. So when the question talks about current, what does that mean? Current is defined as the charge flowing. So now you understand one very important thing. Very, very important question that directly comes right. For example, if I say what is the charge of one electron? That is minus 1.602 into 10 raised to the power minus 19 coulomb. What is the charge of one electron? It is going to be one electron is going to be 1.602 into 10 ki power minus 19 coulomb. Yes or no?
Yes.
Okay. So you understand, can I say 1.602 into 10 raised to power minus 19 coulomb contributes to one electron only.
Yeah.
Got the point?
Yes.
So 1 coulomb of charge contributes to 1 coulomb of charge makes 1 by 1.602 into 10 raised to power minus 19. These many electrons. Yes or no?
Yes.
So now you understand, if let's suppose I replace that. So 1 coulomb, if I solve this value, this comes out to be 6.25 into 10 raised to power 18 electrons. What does that mean? That if I am saying that there is a 1 coulomb of charge, how many electrons do you think it is going to contain? So when I say it is 1 coulomb of charge, this is exactly going to be 6.25 into 10 raised to power 18 electrons. Yes or no?
Yes.
So if I say I have 2 coulombs of charge, then
2 into 6.25.
right. So basically double of it, right? So if I say 3 coulombs of electron, so can I say if I have q coulombs of charge? If you have q coulombs of charge, so how many electrons in that?
Q
Q
into
into 6.25 into 10 raised to power 18 electrons. But Q has to be coulombs, yes or no?
yeah.
Got it? So you understand this part that if I know the number of electrons present in 1 coulomb, now what do I say? When I say current, what is the difference between current and charge? Charge is generally static.
Hmm.
That means placed at one point. But when I say current, current means flowing charges.
Yep. Depends on time.
Current means flowing charges,
Yeah.
right? So current basically means what? Flowing charges. Got the point? So when current basically means flowing charges, what does that mean? Just tell me. Then current flowing charges per second.
Hmm.
So when I define current, I say it is the charge passing through a point per second.
Any upon T.
That means I is going to be Q by T.
Yeah.
Yes or no? Because if I take a conductor and if I take this point, you understand how many electrons actually cross through it.
Yeah.
So how many electrons exactly cross through it? So let's say if I say 6.25 into 10 raised to power 18 electrons cross through it in 1 second.
Hmm.
What does that mean? What does that mean? Just tell me.
Its current will be 1 ampere.
Yes. Because it is actually 1 coulomb per second.
Yeah.
So can I say Q is going to be current into time, where time is in seconds?
Yeah. Yes, ma'am.
Okay. So now have a look at the question. So the first formula that I derived here was that the weight deposited here is going to be equal to what? Q into Z. That was ZQ. Instead of Q, can I say ZIT?
Yes.
That is the weight of the metal deposited at cathode during electrolysis. Yes or no?
Yes, ma'am.
That is the weight of the metal deposited during electrolysis. Understood my point or no?
Mm.
So W here is going to be equal to what? Z I T.
Yeah.
Understood?
Yes.
Any doubts in this? That's the point. So you understand that when W is going to be ZIT, what exactly does that mean? That ma'am, whenever we have this kind of scenario, right? So the formula here becomes ZIT. Z is what? Molar mass of the metal.
Yeah.
Yes or no?
Mm.
Divided by valency of the metal into 96500. So this is going to be the weight. Or in chemistry, there is no difference between mass and weight. So mass of the metal deposited. Got the point or not?
Yeah.
Yes or no? So
Yes.
that is the answer. So W here is going to be GMMIT upon N into 96500. Got the point?
Yes.
Got it?
Yes.
So that's the formula. So let's suppose the question says that 5 amperes current is passed through a solution of is passed through a solution of NiCl4 for 3 hours, or I would say AlCl3. Calculate the amount of aluminium deposited on cathode. So you know that if whatever may be the solution, aluminium will be present as Al plus 3. And Al plus 3 thereby would be what will be my cation? Yes or no?
Yeah.
Al plus 3 will be what? Will be my cation. And it is going to gain 3 electrons. This is going to form aluminium solid. Yes or no? Al plus 3 will be what? It is going to form aluminium solid. Yes or no?
Yes, ma'am.
So when this happens, so Al plus 3 will basically do what? It is going to gain 3 electrons.
Yes, ma'am.
So it is molar mass is going to be 27 grams, and this is 3 moles electron. So 3 mole electron is basically going to be what? 3 Faraday charge.
Yes.
So can you simply apply the formula that W is equals to ZIT ZIT? Z is what? GMM of the metal divided by valency of the metal into 96500 into current into time is going to be the weight or mass
Mm.
deposited. So here weight is going to be what? Z is what? GMM of the metal is 27 grams. Current is 5 amperes. We are passing it for 3 hours. So 3 hours is going to be 1 hour. 1 hour is going to be 60 minutes into 60 seconds into 3. So this is going to be 3600 into 3. This is going to be 10800. These many seconds. Time has to be in seconds always divided by the valency of aluminum is plus 3
Yeah.
into 96500. So this is exactly going to be the weight. So 3 nines are 2 zeros get cancelled. So my answer becomes 9 times 5 into 108 divided by 965, and that is going to be W.
Yes,
Are we
ma'am.
understanding?
Yes, ma'am. Got it.
Any doubts in this?
No, ma'am.
मुझे पता ही नहीं था I had so many extended family members.
Miss, will it be like gram or gram per mole?
Grams.
Yeah.
Okay, ma'am. Yeah.
Every
Understood?
Yes.
people got job group.
Yes, ma'am. Got it.
Correct.
Hmm.
So that's the formula that we have with us. All right.
Yes.
Any doubts in this?
No, ma'am.
All right, perfect. So this is how we calculate the mass of the metal which is getting deposited on the electrode. Got it?
Yes.
So we're going to keep this much class today, 40 minutes, because I joined late. So sorry for that.
Hmm.
Right?
She was perfectly fine. सुबह खाना वाना बनाई सब कुछ थी उनको था ना उसका इशू but she was